Hi everyone, welcome back to my channel. So in today's video we are going to talk about UVM, and I have already made a video on some basics of UVM, but guess I'm not regular about UVM sessions. Sorry for that, because I'm having back-to-back classes courses like Verilog and System Verilog to students, which is why I'm busy in uploading for uploading the classes. But guess I'll be uploading at least 2 classes in a week because many students are waiting for my UVM sessions, which is why I will be trying to be consistent on uploading UVM sessions. And before getting into today's video, please subscribe to my channel and hit on the notification bell also. And if you are some VLSA aspirant who want to enter into design and verification domain, you can subscribe to my channel. And yeah, let's get into today's video. In today's video, we are going to talk about introduction to UVM and UVM architecture. We are going to study about UVM architecture today, and before going into UVM architecture, let us see some basic introduction on UVM. I have already done it in the previous sessions, but yeah, just think it as a revision session on before sessions. And yeah, uh, so you all know that what is UVM. UVM stands for Universal Verification Methodology. So this is the standardized approach to verify complex digital designs by using System Verilog. So what does UVM provides? It provides set of libraries, classes and guidelines for all the verification engineers in order to create reusable, scalable and portable test benches. Right? Now the important question is, why do we need UVM? We already have SV, we are already creating test benches in System Verilog. But then why do we particularly need UVM even though we are having SCV? We all know that SV is a powerful HDL or HPL tool which is used to create robust environment test benches for verification engineer. Then we are having lots of advanced features like oops, assertions, randomization. So by even though we are having all these various powerful features within System Verilog, why do we again need UVM? So the important thing that SV lack is it doesn't provide some framework or guidelines in order to develop test benches in a uniform manner between different teams. That means every, for example, in system in real field you are having every verification team will be having different IPs. So for example, if one IP team want to connect with other IP team, like each IP team will be having their own test benches, right? Every IP team will be having their own driver environment monitor. So every IP team will be having their individual components. So whenever all these IP teams need to be integrated or connected for communication, this doesn't happen in SV because SV doesn't have this particular framework or guidelines in order to integrate all these different teams, right? This is where UVM comes. UVM has the ability, UVM is a providing set of guidelines or framework in order to connect all these teams, in order to make all the components of all these teams communicate with each other. So this is what SV lacks, and this is where UVM is used. And because of all this integration and everything, in by using UVM, you can create a test bench which is more modular, more reusable, and more suitable for complex design test benches. Right? So this is why we need UVM. Now coming to what are the advantages of UVM over SV? First is lack of standardized architecture. So what does this lack of standardized architecture mean? In SV, as we already talked, every design or every team need to build all its components like driver, monitor. Every team needs to be built everything from the scratch in SV. But in UVM, it provides a standardized modular blueprints for all the components like driver, sequencer, agent. So everything will be having a standardized model blueprints. teams, and which is why it will make all the teams to have to understand it easier, and to maintain and scalability is also easier in UVM. Now coming to the second point, which is poor reusability and modularity. As we have already talked before, one IP team can't be connected with other IP team in system Verilog, which is why the reusability is also less in UVSV compared to that of UVM. So in UVM, since the integration is possible between different teams, so the reusability and modularity of various components is also easy in UVM compared to that of SV, right? So this is the second point. Now the third is no built-in stimulus generation. So in SV is always limited to some basic initial blocks or some randomization loops. Okay, we don't have any built-in stimulus generation in SV, but in UVM we are having a built-in sequence libraries. Okay, by using this built-in sequence libraries, you can easily generate a complex randomizable stimulus pattern in system in UVM compared to that of system Verilog, because in system Verilog you need to do that manually, but in where UVM you are having a built-in sequence libraries which will generate the complex randomizable layered stimulate generations. Okay, so this is the third advantage of UVM over SV. Now coming to the fourth one, which is on absence of configuration and factory patterns. So for example, whenever you want to replace, whenever you want to replace, for example, you are having some driver component and monitor component in your architecture, right? So your monitor is suddenly, your monitor component, there is there are some bugs, and then you want to replace your monitor, right? So it is not easy in system Verilog, because whenever you want to change, or whenever you want to do any changes within the components or within anything in system Verilog, you need to write a code which is enormous, right? But in UVM you are having a configuration database and factory generations which will help you to easily change the components which are buggy, right? So it is very simple compared to that of system Verilog. This is again another advantage of UVM over SV. Now coming to the fifth advantage, which is lack of standardized communication. As I already discussed previously, in SV, component to component communication is very um, like is often done manually. Here in SV, if you know SV, you know that every communication within SV is done by using mailboxes. So we need to create mailboxes. We need to customize the mailboxes in order to have a communication between component to component. And also the creating the mailbox is also very hectic in thing, right? Because but in system Verilog, in UVM you are having TLM ports, which are transaction level modeling ports. Okay, by using this TLM ports, the component to component connection is done very easily, and it is done in a standardized abstract data movement between verification components. It is done in the standardized way. The communication between components is done by using TLM ports, which is far more easier than that of mailboxes that we are using in system Verilog, right? So these are the advantages of UVM over SV. Now, coming to what are the cons of UVM, we can't say that these are basically the cons, but UVM is having a high learning curve. It is very enormous compared to that of system Verilog. So, whenever you want to develop a small test bench designs, you no need to go for UVM. You can just develop some test bench. For example, you want to develop a test bench code on FIFO. Okay, you no need to learn UVM for developing a test bench of FIFO. You just need to understand system Verilog basic concepts, right? So for simple test bench designs, you need to go for UVM. You can just go for system Verilog, right? These are the advantages and disadvantages of UVM. Now coming to UVM class hierarchy. So, what is we have already discussed about this class hierarchy in the previous sessions, but in today's session I am just going to give you a basic idea on what is this UVM class hierarchy. Okay, UVM class hierarchy is very important, and some of you have complained about I am not explained clearly about this UVM hierarchy in my previous session. Yes, I will be doing one more video clearly on all the components within the hierarchy, right? But as for now, just I'm giving you a basic introduction on what is UVM hierarchy. So basically, UVM class hierarchy is categorized into two branches. Okay, so basically UVM void is the parent class, and UVM object is derived from UVM void. And again, object is again categorized into two branches. One is sequence branch and another is component branch. So basically, it is having UVM object is the parent class, and here it is having two child classes, which is sequence class and component class. Okay, again within sequence, again you are having sequence is derived from UVM sequence item, which is again derived from UVM transaction. Okay, so here UVM transaction is the parent class, UVM sequence item is the child class, right? And then UVM component is the base class, which is derived from UVM report object, right? Again, within UVM component, you are having various components like UVM sequencer, UVM driver, UVM monitor, UVM agent, UVM scoreboard, UVM environment, and UVM test. So basically, this is the hierarchy. Okay. So simply speaking, we are having two branches, which is sequence branch and component branch. Okay. Sequence branch is having sequence item, sequence, and transaction, right? And then the component branch is having UVM driver, UVM monitor, UVM sequencer. So all these things are there within the component branch, right? So now, for example, what does this UVM driver, UVM monitor, what does this basically do? So, UVM driver, monitor, these are the parent classes for your user defined driver class. Okay, this is not present in System Verilog. In System Verilog, basically, whenever you want to derive a class driver, you will just write a class driver, and you will be writing, you will do the same thing for UVM monitor, like monitor also, class monitor, again the body of the monitor, and then end class. Okay, so in UVM also you do the same thing. This is the user defined driver class and user defined monitor class, but the extra thing that you will do in driver class is that whenever you want to define the class, you need to derive it from UVM driver. Similarly, you need to, if you want to define a monitor class, first you need to derive that monitor class from UVM monitor. Okay, so what you will be doing, you will be deriving the driver class from UVM driver, you will be deriving the monitor class from UVM monitor, similarly UVM scoreboard, and all other components also. Whenever you want to create a user defined class, you need to derive it from the parent class, right? So now what advantages are we having by deriving all this from UVM driver and UVM monitor and all? So this UVM driver or UVM monitor are the uh, parent classes which will be having some built-in functions. Okay, so whenever this driver class is derived from UVM driver, what can this driver class do? It, along with its basic functions, it can also use the built-in functions that are present within the UVM driver. Similarly, UVM monitor can use the built-in functions within the monitor for its child class of class monitor, right? So in this way, all the user defined class can use the built-in classes, built-in functions or built-in methods that are present within UVM driver, UVM monitor, etc. So in this way, what happens, as we have already discussed before, the everything will be in a framework, everything will be having its guidelines, and also because of this, the reusability of within the team or within various components is also become very flexible, right? So this is about the UVM class hierarchy, and in upcoming sessions we will be talking deep about UVM class hierarchy. Don't worry about that. Right now, coming to today's concept, which is UVM architecture. So we all have seen SV architecture, right? SV architecture is similar to UVM architecture, right? Similarly, in SV architecture also we are having monitors, driver, right? We don't have the sequencer within our SV, and also this is one of the new concept, which is agent. In today's video we are talking about this agent, and then again scoreboard, which you will see in SV also, and then environment, and then test, and then top, right? So environment, so the test is within the within test you are having the environment, and within environment you are having various components like monitor, sequencer, driver, okay, and all this monitor, sequencer, driver are within the agent. Now the agent is going to communicate with DUT through interface, right? So the communication between agent and DUT is done through interface. So basically this is the UVM architecture, similar to SV architecture. If you don't know about SV architecture, or if you want to revise the SV architecture, I'll link that here. You can just go to SV architecture for just a idea on how the working of architecture, various components will be done, right? So today I'm not going to explain anything that already you know about in SV architecture, like environment, scoreboard, driver, monitor. You have all seen about all their things within the SV architecture also. So in today we are going to talk about agent. Okay, this is one extra important concept that is present within UVM. You don't see agent in system very long, right? So apart from that, you already know that, so driver is used in order to convert the basic transaction into pin level transaction, and then the monitor is used to monitor all the signals that it get from DUT. You already know the thing, what does the monitor and driver do. So in today's video we are going to talk about agent. So basically agent is very important within UVM, right? So what does this agent do? Basically agent is always protocol specific in UVM. That means depending upon the protocol we can adjust this agent. So we can call it as, we can configure the agent based on the protocol that we are having. So again, agent is categorized. So how are we going to configure it, or how are we going to make the changes within the agent? So we are going to see it. So firstly, agent is categorized into two types. One is active agent, second one is passive agent. Okay, so what does this active agent and passive agent mean? So whenever the monitor and driver and sequencer, so whenever all these components are active in nature, then that is the active agent. Okay, whenever the monitor and, sorry, whenever there is only drive monitor is active and the driver and sequencer are inactive, then we call it as a passive agent, right? So what is the use of this active and passive agent? Like, you all know that driver is used to drive the values or something into the DUT, right? So whenever the values are needed to be driven, or whenever the input or data need to be driven to DUT, then we go for active agent. Okay, because in active agent monitor, driver and sequencer are all active in nature. Now whenever you want to only observe the particular whenever you want to see, only observe the operations. Whenever you want to see the data flow and everything, if you just want to observe a thing and you just don't want to drive anything, then you choose passive agent. Because in passive agent, driver and sequencer are in deactive mode. Okay, that means they are in a deactive mode, they are not working. So whenever driver or sequencer is not working, basically you know that driver is used to drive the value. So whenever the driver is off, obviously the values won't be driven to DUT. So only monitor is present. So you all know that what is the work of monitor, it is just used to monitor the values. So only when you need to observe the values, only when you need to observe the data flow, you choose passive, and when you want to drive the values, you choose the active agent. So this is the difference between active and passive agent, right? So apart from this active and passive agents, everything is common within UVM architecture, right? So that is all for today's video, and in the upcoming sessions we will be talking about UVM hierarchy, various classes within UVM hierarchy. Because recently someone has complained me about only speaking about UVM sequence and UVM components and not talking about UVM void or UVM root. Because again, in UVM report objects, so all these things I will definitely explain clearly about UVM hierarchy in the upcoming sessions. Okay, if you like this video, please do give it a like, and also share this to all the VLSA aspirants who also want to learn UVM. Right, so that is all for today. Thank you all.